Fractions and ratios often appear similar due to shared notation, but they represent fundamentally different concepts. Let's explore the mathematical boundary between them. The expression 3/4 can be interpreted in two distinct ways: as a fraction representing parts of a whole, or as a ratio comparing distinct quantities. This duality arises from using the same notation for both. Fractions subdivide, measuring part-to-whole relationships on a continuous number line. In contrast, ratios combine, comparing distinct quantities that may not even be physically alike. To convert a ratio to a fraction, distinct parts must be summed to create a new whole. For example, a 5:3 ratio of boys to girls becomes a fraction of 5/8 when considering the total class. Ratios can scale infinitely, comparing multiple quantities simultaneously. Fractions, however, are strictly binary, comparing a single part against a whole, making multi-term fractions impossible. A ratio like 5 is perfectly logical, describing an undiluted substance. However, mathematically, dividing by 0 is undefined, highlighting a fundamental difference between ratios and fractions. In scenarios like baseball statistics, fractions can obscure reality, while ratios preserve real-world contexts. Proportions are additive, providing a clearer picture of performance. Ratios are just one node in the fraction ecosystem, which includes various interpretations like part of whole, operator, quotient, and measure, each offering unique insights. The diagnostic matrix highlights key differences between ratios and fractions, from core relationships to mathematical identity and context dependency, illustrating their distinct roles. While all fractions are ratios, not all ratios are fractions. Ratios offer a broad universe for comparing quantities, whereas fractions are specific part-to-whole ratios functioning as precise mathematical numbers.